Hi, good morning, friends. Today we are going to deal with operation research, and the unit name is here transportation problems. In transportation problems, the top unit is divided into two parts. First part deals with transportation, and second part deals with assignment problems. In this lecture, we are going to deal with assignment problems. In the later on lecture, we will deal with transportation. So let's start with assignment problems. Basically, first thing is that what is assignment problems? Assignment problem is a special kind of transportation problems in which each source would have the capacity to fulfill the demand of any of the destination. In the assignment problems, there are two types. First type is your balanced assignment problems, and second type is your unbalanced assignment problems. In the balanced assignment problems, we are having a matrix which is in a form of the square matrix, means that the number of the row given is equal to your number of the columns. So in this given example, you can see easily that the number of the row is your 4 and the number of the column is your 4. So this is the type of the square matrix. Now second type is your unbalanced assignment problems. In the unbalanced assignment problems, the matrix given in a problem is not in a form of the square, because it will be having the number of the rows is not equal to the number of the column. Here you can see easily that the number of row is your 4, number of row is your 3, and number of column is your 4. So it's not equal. So to deal with such kind of problem, we have to convert this unbalanced matrix in balanced form, means that in the square form. We can do such activity by introducing in a dummy row. Dummy row consists of the element which is having 0 values as a element. So now we will deal with the basic problem of the assignment. So in this given problem, solve the following assignment problem using Hungarian method. The matrix entries represent the processing time in hours. Basically, whatever the assignment problem will be given, we are going to solve each by Hungarian method. So in this given, the elemental values is in hours. So we are going to solve this given matrix by the Hungarian method. By the step by step, we will see the procedure. So first step, in step 1, in the step 1, write the matrix as it is. These are 9, 11, 14, 11, 7, 6, 15, 13, 13, 10, 12, 13, 6, 8, 8, 11, 9, 10, 12, 9, okay, 7, 12, 14, 10, and here 14. Here it is your job. 1, 2, 3, 4, 5. Here it is your operator. 1, 2, 3, 4, 5. In the first step, in step 1, you have to find the row minimum value. Means that you have to select the minimum values from the respective row. So in this row, if you will see, you are having a minimum value as a 7. In this row, you are having a minimum value as a 6. In this row, you are having a minimum value as a 6 again. Here you are having a minimum value as a 9. In this row, you are having a minimum value as a 7. So in this step, we got the row minimum value, and this row minimum value we have to subtract from the respective row of the elements. So in this row, we have to subtract it by 7. Each element of this row I have to subtract it by 7. So 9 minus 7 is your 2, 11 minus 7 is your 4, 14 minus 7 is your 4, 7, 11 minus 7 is your 4, 7 minus 7 is your 0, 6 minus 6 is your 0, 15 minus 6 9, 13 minus 6 7, 13 minus 6 7, 10 minus 6 4, 12 minus 6 6, 13 minus 6 7, 0 2 2. Again we have to subtract this row with the 9. So 11 minus 9 is your 2, 9 minus 9 0, 10 minus 9 is your 1, 12 minus 9 is your 3, 9 minus 9 is your 0. Now here in the fifth row, 7 minus 7 0, 12 minus 7 5, 14 minus 7 7, 10 minus 7 3, 14 minus 7 again 7. Now this I got the new matrix. Now in the step 2, in the step 2, what you have to do? Now select here the now we have did the row operation in the step 1. In the step 2 we have to do same thing but in the column. So how you have to do? You have to select the minimum value from the column. From each column you have to select the minimum value. What you are going to get here? From in this column you are going to get as a 0. Here you are going to get again 0. Here again you are going to get 0. Here you are going to get as a 2. Here you are going to get as a 0. Okay. So in step 2, you have to subtract the minimum value of the column with respective column. With all the elements of the column you have to subtract this minimum value. So we will again get the new matrix. This is 1 2 3 4 5, 1 2 3 4 5. Since in this column you have to subtract it by 0. By subtracting within a 0 we will get the same element value of the column. So write it as it is 2 0 6 2 0. In the next column again we have to subtract it by 0. So we will get element values as it is 4 9 7 0 5. In the third column again we have to subtract it by 0. So we are going to get the same matrix. So as it is 7 7 0 1 7. Now in the fourth column we have to subtract it by 2. So we will get 4 minus 2 is your 2, 7 minus 2, 7 minus 2 I'm going to get 5. Okay, 2 minus 2 is your 0, 3 minus 2 1, 3 minus 2 1. Again now in the fifth row we have to subtract the element values with the 0. After subtracting within a 0 we are going to get the same value of the column. So writing the as it is 0 and 7. Now step 2 is my over. Okay, now in step 3 write the matrix as it is. Write the matrix as it is. Two 4 7 2 0. Okay, 0 9 7 5 4 6 7 0 0 2, 2 0 1 1 0, 0 5 7 1 7. Write the job number 1 2 3 4 5, operator number 1 2 3 4 and 5. Now in step 3 we have to do initially in step 3 we have to do the row as well as column operation at a time. Okay, but in a sequence. First we have to do in the row operation, and then after completion of the row operation we have to go for the column operation. What is that here? A row operation means that in this row you have to select the 0 value. Here if it is having a single value then you have to square it keep it in a box and cancel that respective column. Okay, now come to the next row. Next row, here you are having again single 0, so you cover it and cancel that respective column. Okay, now come to the next row. Here you are having more than 1 0. Okay, if you are having more than 1 0, then you have to skip that row and move to the next row. Now come to the fourth row. Here you are having again single 0, so select it and cancel that respective column. Now come to the next row. Here you are having no 0, so skip that part and now move to the column operation. In the column operation also we are going to do in the same procedure. Okay, but here we have to cancel the row. Now this is my column. Okay, here we are having a single digit as a 0, so selecting this, keeping it in a box and cancelling that row. Now there is no further 0, so my step 3 is mine over. Now come to the step 4. In this step 4, what you have to do? Step 4. See here, this is your intersection point of the two cancellation line. Here it is also one cancellation line, and here it is your horizontal cancellation line. So this is your intersection point. Here also it is a vertical cancellation line, and here it is horizontal cancellation line. So here is your one more intersection point, and here if you will see again you are going to get an intersection point. Okay, now you have, now see these, the remaining values 7, 2, 7, 5, 1, 1 and 7, 1. From these remaining values you have to select the minimum value. So minimum value in these is your 1, so you have to circle it. Okay, now wherever there is an intersection point, you have to add this value. And next, wherever there is no cancellation, see here 7, 2, 7, 5, 1, 1, 7, 1, these are not cancelled. So in this case, in this element you have to subtract it with 1. Okay, and wherever there is a cancellation but there is no intersection, here is only one cancellation but there is no intersection of the two cancellation line, so you have to keep this element as it is. So step 4 will be, so then step 4, here is your operator number 1, 2, 3, 4, 5, job number 1, 2, 3, 4 and 5. Since it is only just cancelled but not intersection, so I have to keep this element as it is 2. Here also 4 as it is. Here it haven't taken part in the cancellation, so I have to subtract this with 1. So 7 minus 1 is your 7 minus 1, 6. Again here it haven't taken part in the cancellation, so I have to subtract it with 1, minimum value. 2 minus 1, 1. And here just taken in a part in a cancellation, so I have to write the digit as it is. In the second row, here same thing, here he haven't taken in a part in the intersection, it is just cancel out, so I have to put the values as it is. Here same thing, here he haven't taken part in a cancellation. Okay, so I have to subtract this value with 1. So 7 minus 1 is your 6. Again here 5 minus 1 is your 5, within a minimum value is your 1, so 5 minus 1 is your 4. Here he had taken just part in the cancellation, so I have to keep the value as it is. Now come to the third row. Here he had taken the part in the intersection, because vertical line is also intersecting and horizontal line, both are intersecting at this point, so I have to add this value with minimum value of the minimum value, that is your 1. So 6 plus 1 is your 7. Again here same thing, 7 plus 1, 8. 0 will be as it is, since he haven't taken part in the intersection, just here get cancelled out, so 0 as it is. again here 0 as it is. Now here 2 here taken part in the intersection, so here we have to add this value. 2 plus 1 is your 3. Now if you will see this value here taken just part in a cancellation, so I have to write it as it is. So 2 0 2 0 here taken here he haven't get cancelled out, so I have to subtract this value within the minimum value of the cancellation element. So 1 minus 1 is your 0, minimum value is your 1. So 1 minus 1 is your 0. Here it is as it is. Again same thing here, 0 5 7 minus 1 6 1 minus 1 0 7 as it is. So I got the matrix step 4. Also see here the allocated values is your allocated values is 4. Allocated value is your 4, but your element values means that number of rows and number of column is your 5. Okay, since the allocated values is not equal to your number of rows or number of column, so in this case the optimization haven't reached. Okay, so we have to move to the step 4 as we had did. Okay, if number of allocated values is equal to the number of row or column, then our optimization has reached here and we have to stop here. But since the number of allocated cell is not equal to the number of the element of the matrix, so we have to move to the step 4 as we did now. So in the step 4 you have to follow again the step 1 from the step 1. In the step 1 what we are going to do, we are going to find in a row minimum value. In the row minimum value, here the minimum value is your 0, again here 0, again here 0, again here 0, again here 0. If you are going to subtract this matrix within a minimum value, that is your 0, we are going to get in a same matrix. So move to the next step. Next step is what? We are going to find in a column minimum value. So column minimum value, again you will see that in each column we are having then a 0 as a minimum value, so it makes no change in the matrix. So again we will move to the next step. Next step is what? Now we have to do in a row and column operation at a time in a sequence. So we are going to with the row operation. In the row operation, we are in this row we are going to see in a 0 value. Here since it is in a single 0, so we have to square it here and cancel that respective column. Again here, again in the second row we are again having the single digit as a 0, so we have to select that and cancel that respective column. Now come to the next row. Here you are having the 2 0, so you have to skip that row and move to the next row. Again you are having the 3 0, so again you have to skip that row and move to the another row. So this is our last row, and this we are having in a single as a 0, so select it and cancel that respective column. Now my row operation is over. As a sequence I will move to the column operation. Same procedure we will follow. In the column operation, select the column, and here we will see the 0 value, 0 how much time it is present. Since it is present only once, so I have to cover it and cancel that respective row. Again move to the third column. Here you will see that you are having a single digit as a 0 here, so cover it and cancel that respective row. Okay, now count the allocated values 1 2 3 4 5. Since 5 allocated values are 5 is equal to your elemental values. Elemental values means that number of row or number of column, that is your 5. Since it is equal, so our optimization has reached. So I will move to the step 6. sorry, step 5. In the step 5 we will find in a total time taken. So how you will find the total time taken? Right here job, here it is your operator, and here it is your time taken. So job 1 2 3 4 5. In the operator, where the allocated values is there, where the allocated value is your 0 here, allocated value 0, it is present here in the fifth operator. So right here fifth. For second row we are having an operator 1, where it comes 0. In the third row the operator comes 0 at for the third operator. So third it is. So fourth row, in the fourth row the operator is 2. In the fifth row the operator is fourth. So now take the question. Take the question. Now match it and write the respective values. So in the first, for the job 1, for job 1 operator is 5. For job 1 operator is 5. So we have to select this element. This is your time taken is your 7. For the second job the operator is 1. For second job operator is 1. So I have to select this. So write it here as a time. For third row operator is third. So third operator, third job, third operator is coming here. So 6 as it is. Now for fourth job second operator, fourth job second operator, it is coming here. So write it here 9. For fifth job the operator is, for fifth job the operator is 4. For fifth job operator is 4, it is coming 10. So write it here 10. Now add this time. You are going to get 6, 13, 21, 38. This is in hours. So total time is your 38 hours. So this is your answer. I hope you had enjoyed. Thank you.